Good morning, guys. Math 1500, summer 2015. I think last week's videos were just right down boring, I got to tell you. But it's this kind of stuff that we got to talk about. We need to know what populations, and we need to know about samples, and we need to know about different types of sampling procedures, so we can, so we can talk and, but communicate about studies. But this actually, I think, starts the fun stuff, the cool stuff. I'm going to show you how to use that big old fancy schmancy calculator that you bought, and we're going to get into some numerical summaries. So the game plan here for this video, it's going to be probably a pretty lengthy one because we're going to do quite a bit. But it's a video that I usually start out most semesters with, showing you how to come up with certain numerical summaries, and I'll tell you what they mean. The cool thing is, once we see how we do this by hand, then we're going to examine how we find the same numbers using the calculator and R. Now, I want you to think about something with me, okay? Let's say that I tell you the following, that I tell you that I am teaching a class, and this class just took an examination and their average score was 80. And I tell you furthermore that my class was very small and had only 3 students. Now, what could you tell me for sure? What could you tell me for sure? Well, some people say, well, I could tell you for sure that somebody scored above 80, somebody scored below 80. Well, not necessarily the case, because all people could have scored an 80. I've heard students say, well, at least one person scored an 80. Well, that doesn't necessarily have to be true either. Well, this is a horrible example, but actually in that situation someone would have had to score an 80. But you can imagine where you could come up with a situation where one of the scores doesn't have to be 80. So guys, when putting these two things together, what do you know for sure? If you have an average score of 80 for 3 students, what do you know for sure? Well, what we can do is we can actually depend a little bit on the formula here. And guys, the symbol for the average score in statistics is X bar. So for the next 10 weeks of your life, well, technically 9 weeks of your life, when you see X bar, I want you to think nothing more than the average score. Now, we'll call that the mean, which is just a fancy way of saying the average. The average score can be found by taking the sum of the scores. Now, this summation sign, a lot of people in sororities and fraternities, it means one thing, but in mathematics it means something else. All it means in mathematics is to add. So this X bar is the symbol for the average. This summation sign, a Greek letter, sigma, means to add. X in statistics stands for the data. If you're taking an algebra class from me, X is something you usually solve for, like X equal 2, X equal 9, whatever it may be. Or it's part of an expression that we simplify. Not in statistics. X is our data. Okay? And N is just the number of scores that we have. So in this situation, N is completely known because it's 3, and it will be known. So guys, if we take this and think about what we know for sure, if the average score is 80, and we know we get that by taking the sum of the scores, and we have 3 of those, then we can multiply both sides by 3 and determine that the sum of the scores has to be 240. So guys, when we say that we have an average score of 80 over 3 students, the one thing that we can say for sure, without question, without hesitation, is that the sum of the scores had to be equal to 240. Now, if you think about it, there's a lot of ways that we can create scores of 240. with 3 scores. Just as I showed you before, we could do 80, 80, and 80, right? That's one possibility. We could do 70, 80, and 90. Those add up to 240 as well. No one said it was a 100-point test. Maybe 2 people didn't show up for the exam and got zeros, and 1 person got a 240. Maybe it was a 250-point test. I don't know. That's kind of cheesy, but it is a possibility. And of course, you could get really, 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 really silly. Negative a million. You'd have to be pretty silly to get negative a million on a test. You'd have to be awful smart to get positive a million. But nevertheless, just to go to an extreme, negative a million plus a million is 0, plus 240 gives you 240, divided by 3 gives you an 80. So guys, in all of these situations, we have the mean equal to 80. But in no way, shape, form, or fashion are these 4 data sets of 3 numbers telling us the same story. So guys, in statistics, we have to make 2 numerical statements. We need to make a center statement and what a center statement does for us in statistics is it kind of gives us a typical score. Now, the 2 center statements that I'm going to teach you in numerical statements is called the mean and the median. I'm going to show you what these things are. I'm going to show you how we define them. And I'm going to show you how to use your calculator to find them. The other thing that we have to do in statistics is make a spread statement. And this just addresses the consistency of the scores. Now, if we come back up and look at these scores here, we can see that 80, 80, 80, these things are completely consistent, right? Whereas if we come over here and look at 0, 0, 240, these are not as consistent. Now, granted, these 2 scores here are. So we want to come up with a measure of consistency within the scores. Now, over here, it's just completely wacky. Jumping from negative a million to 240 still has an average of 80, but in terms of the consistency of the scores, there's nothing whatsoever consistent about those 3 scores. So we want to come up with spread statements as well as center statements to address the consistency of scores. Completely consistent, kind of consistent, a little bit consistent, and this would be just completely and totally inconsistent. This would have a lot of variability where this one has limited variability. Things we're going to look at are the range. We're going to talk about quartiles. And we're going to talk about something called a standard deviation. Now, the standard deviation ends up being a formula that's really, really ugly. But guys, when I teach this class, I don't teach this class trying to turn you into a math major. I realize that almost all of my students in Math 1500 are psychology majors, nursing majors, history, whatever it may be. You're not math majors. So I'm not trying to turn you into a math major. Now, if my class inspires you so much that you want to turn around and be a statistics major, well, I'll be really proud and really happy. But that's not my goal. My goal is to try to prepare you to encounter statistics every day in your life, and you will every time you pick up a paper, every time you log on the internet. If you go on one of these news sites, statistics is everywhere, and I'll end up eventually showing you examples of things like that. Usually they do it wrong, and I'll show you how to detect that. But I'm more interested in just showing you how statistics applies to your life and how it applies to your upcoming job. Okay, now, gang, the scores that we start out with are 78, 82, 60, 80, 92, 79, and 47. So the first thing I want to illustrate to you are the measures of center. And along the way, I want to tell you not only what the answer is, but I want to tell you about the interpretation. So guys, the first one is the mean. And remember, from here on out, the mean is nothing but the average, and we find it by taking the sum of the scores divided by how many we have. So guys, what we want to do is we want to add 78 plus 82 all the way up to 47. And we have 1, 2, 3, 4, 5, 6, 7 scores. So we can put this in our calculator. Guys, my calculator's over on my desk, so hold on just a second. All right, so hopefully you've got this in your calculator. So when I add this up, I get 518 and 7 scores. So I get 74.00. So guys, I get a mean of 74.00 for these scores. Now guys, it's customary when getting numerical summaries to round our answers to 2 places. So 74, obviously 0.00. I don't even know what I could say about that. So all we would say here is 74 is the arithmetic average. That's all we would say. See, gang, statistics doesn't have to be hard. It can be easy, but it will get kind of hard. So the next thing that we look at in statistics is the median. And guys, I don't know why in the world that my on-screen capture device likes to reset, but it's annoying, and I'll try to keep it in the wide version for you. Now, the median is the center number when our scores are arranged from low to high. So guys, the first thing I have to do is I have to come up here and take these numbers and arrange them from low to high. So I see that my lowest score is a 47. My next lowest score looks like it's going to be a 60. My next lowest score is a 78. My next is 79. My next is an 80. My next is an 82. And my highest score is a 92. Now guys, if we walk our way in, and I kept this data set small and manageable, you can see that the center score here is 79. So we can say that the median is 79.00. Now, for some reason, statisticians are obsessed in their interpretations with percent below. Now, we'll get into, here in about 4 or 5 weeks, we'll get into something called a percentile. But when we interpret measures of location, and that's exactly what this is. This is a measure of location. This is the location of the center of our data. It comes in and splits our data into 2 equal parts. But it's equivalent to say that approximately half of our data is above 79 as it is to say half our data is below. But when we make interpretations, we usually speak in terms of location as the percentage of scores below. So what I would say here in describing the median is I would say approximately 50% of the exam scores are below. Actually, that should be is below, but below 79.00. So guys, that gives us kind of a fulcrum, if you will. It gives us a kind of a leveling point. Now, something to put on your radar and something to kind of think about is, notice we have two measures of center, the mean and the median, and they give us two different numbers. And a lot of students are like, well, which one's right? Well, they're both right. They just do different they're different tools for measuring measures of center. We're going to get into a situation where this one's going to be better than this one. We'll get in other situations where this one is better than that one. But that's, to be learned later, possibly be learned this week, actually. All right, gang, so we're done with the measures of center, the mean and the median. The mean was 74, the median was 79. We now know what those mean. So now we're going to focus our attention on measures of spread. Now, the easiest measure of spread that we can look at is called a range. And the range is nothing more than the maximum value minus the minimum value. Now again, guys, remember, this x is not a variable as much as it is in an algebra class. This x just says the maximum of our data set minus the minimum of our data set. And we saw that the maximum value was 92. And we saw that the minimum value was 47. So if my mental arithmetic is correct, our range would be 45. Rounding to two places, it'd be 45.00. And guys, this is nothing more than the distance from our high score to our low score. So the range is really easy to find, but in many ways the range doesn't tell us much. Now, let me tell you a problem with the range, guys. In statistics, we run into things called outliers, and outliers I would define to be unusually high or low observations relative to the other scores in our data set. Now, the reason that we have to bring in this relative to, let's say that we have a student at Shawnee State University that's 6 foot 8 inches. Relative to the heights of other students at Shawnee State University, is that an unusually high or low observation? Absolutely yes. There is no doubt in my mind that if we were looking at examining the heights, well, guys, I told you, dogs will go crazy. Trash truck went by and I forgot to put the trash out. The dogs are going insane. So, but just get used to it. That's going to happen. They can sit all day long and probably won't bark at anything, but as soon as I get on here to put up a video, they'll start going crazy. So anyway, that's my ranting for the day. Well, they found something else to bark at now. Huh. All right, I guess if you're a dog, you just got to bark, right? So anyway, a student at Shawnee State University, if we were going to examine the heights of all of you guys, there is not a question in my mind that the presenter decided to just quit. Okay, all sorts of wacky stuff going on. So this person's height would be extreme. It would be clearly a high observation compared to other students. However, if we were examining this height for NBA basketball players, this would be very typical, and in fact, it'd be very close to the mean. So we wouldn't expect 6'8" to be an unusually high or low observation in NBA basketball players. So again, keep this definition of outliers close at hand. Now, outliers drive you insane. They drive you absolutely crazy when you're doing statistics or collecting data for something that really matters, like a project or something, because there are certain statistical techniques that I'll teach you that are very sensitive to outliers. So, but we need to be able to identify those. Now, why does that even matter when it comes to the range? Well, guys, imagine if we had the following scores: 10, 11, 12, 13, and 92. Well, our range here would be 82, but you can see that this value is kind of artificially inflated simply because of this one value. Well, this 92 is clearly outside the range of 10, 11, 12, 13. So relative to the other scores in the data, 92 is unusually high. And 92 has a big effect on our range. 80% of our data ranges from 10 to 13. But then we have this one outlier here that artificially inflates that. So the range really isn't a cool measure of spread because it is so artificially inflated by outliers. So guys, when you have outliers, you want to be really, really, really careful on using the range for much more than just to report the difference in the high and the low. Now, let's stop just for a second, and I want to ask you a question. On our first exam, which will come up very quickly just because of the unusually fast pace of summer classes, do we want a high range or a low range? What do we want? What do you think? Guys, I want a low range. I don't want a lot of variability, but it depends. And this is a classic example of where from here on out, that center and spread are not separable. For example, let's say our range is equal to 10. Are we going to be happy with that? Well, I am. If our scores range from 90 to 100, I'm going to be very happy. But if our scores range from 40 to 50, I'm not going to be happy. So this is smiley face. This would be frowny face, right? So, you know, where these scores would be centered. These scores would be centered around 95. These scores would be centered around 45. So the range doesn't tell the whole story, just like the average of 80 previously when I talked about having three scores that averaged up to be 80. What did we know? Where the scores are centered along with the variability, these two things now go together to tell a comprehensive story, a more collective story, if you will, about our data set. So guys, from here on out, it's not all about the mean and the median. It's not all about the range and some other things I'm going to teach you. It's about putting these two things together to come up with where our scores are centered and how much spread or variability or consistency we have in those scores around the center. Now, speaking of, we get into something called quartiles. And guys, just think about, what does the prefix of quartiles tell you? Tells you force, doesn't it? So guys, imagine if you had a board or a piece of string or whatever it may be, and you wanted to cut your, let's just say a piece of string, and you had a piece of string and you wanted to cut it into 4 equal pieces. How many cuts would you have to make? Well, I would make a cut in the center. I would have 2 equal pieces. And then I would have a cut right there, and then I would make another cut right there. So I have 1/4 of my string here, 1/4 of my string there, 1/4 there, and 1/4 there, right? Well, guys, this isn't a class in strings. This is a class in data. So imagine having your data where you have the minimum value arranged from low to high all the way up to the maximum value. So you end up essentially with 5 locations. A starting location, the location where you have 25% of your scores below, this location where you have 50% below, this location where you have 75% below, and of course you have the top score where you have 100% below. Okay? Well, guys, when this is our data set, we already know that the cut in the center is called the median. Well, this cut right here we call Q1, and we call this cut Q3. This is the first quartile, and this is the third quartile. So guys, we can go back to our ordering of our data when we had listed from low to high, and we can come in and do what? We can see that for the data below the median, these 3 scores right here, 47, 60, and 78, the median of those scores would be equal to 60. For the data above 79, the median of those scores would be 82. So guys, when we go back to our numbers here, this minimum value is 47. We saw that the median was 79. We saw that the maximum value was 92. Now this Q1 right here, this is the median of the scores below the median. And we saw that this was 60. And we saw that Q3 was 82. So, one thing, how do we define, what does this 82 tell us? It's the third quartile. And there's 75% of the scores below it. So our Q3 is 82. And we describe things in terms of location as percent below. And 75% of the scores below it. How would we describe the 60? Same thing. It's the first quartile. And there's 25% of the scores below it. Now, guys, if you look at what we created right here, we created 5 numbers, didn't we? Statisticians aren't real creative, I tell you right now. And we give that a name called the 5-number summary. So guys, the 5-number summary consists of the following. Consists of the minimum value, Q1, the median, Q3, and the maximum value. Okay? So gang, our 5-number summary is 47, 60, 79, 82, and 92. These are the numbers. I'm on currently on 2 doctoral dissertation committees. And these are numbers even at that level that people, these doctoral students will report on the data they've collected for something as serious and as important as their doctoral dissertation. Now, notice that the quartiles are a measure of spread around the median. Right? Let's go back again to our picture right here. Quartiles give us a measure of spread when centered around the median. So you may be interested, I hope you are, in what is the measure of spread around the mean. That's what you all were sitting there wondering, weren't you? Now, you're probably sitting there wondering, Darbo, how much longer are you going to talk? Because you've been talking a long time. Well, I got a lot more to say, so hang on with me. All right, gang. Here's what history shows. Back, I'm thinking about late 1800s, and don't hold me to that. I typically know this kind of stuff, but I don't know this for some reason. But back, okay, a long time ago, I'll take that approach. All they had was the median and quartiles. They had the mean, but they didn't have actually a measure of spread that was built around the mean. So some statisticians got together and they thought, you know what, let's do this. Let's arrange our data from low to high. And instead of coming in for the median, let's come in and look at the mean as a center. And let's try to get an average distance from the mean. So we're going to look at all these distances from the mean, and we're going to add them all up. In this case, we would divide by 7, and we're going to get an average distance from the mean. Now, history shows this is what they actually did. They created a table of values. And they started out with the data set. Now, our data set is, and I'm sure they didn't have these numbers. That would have been kind of freaky if I just happened to randomly choose 7 numbers that they used. So I'm not depending on that one, guys. And what they decided they wanted to do is they wanted to come up with an average distance from the mean, right? So they said, well, let's just see how far each of our scores falls from the mean. We'll add all those scores up and divide by, in this case, 7, and life will be good. Well, I don't know whether life will be good, but at least they'll come up with some sort of measurement that will give them an average distance from the mean. Now, we saw earlier, guys, that the mean was 74. So this first observation, 78, if we subtract it from 4, it tells us that 78 is 4 units above the mean. 82 minus 74, it tells us that this score is 8 units above the mean. 60 minus 74 gives us a negative 14, so it tells us that 60 is 14 units below the mean. So you probably see what they were trying to accomplish here. So that's 6 units above the mean. What is that, 18? I think so. 79. So that's 5 units above the mean. And then 47 is 27. 74 is 27 units below the mean. So guys, you can see what they wanted to do. They wanted to get these numbers, how far above or below the mean these scores are, and then they want to get an average. So guys, if we sum up these x minus x bars, what do we get? And what we end up doing is once we get this, we'll divide by 7 and we'll get an average distance from the mean. Okay? So let's get out of this and go into our calculator. So I have the first is 4 plus 8 minus 14 plus 6 plus 18 plus 5 minus 27. Kind of a drum roll, please. What are we going to get there? We get 0. All right. Well, that's weird. It's actually not weird. I knew I was going to get 0. So, guys, when we do this, we get 0. And the first time they got this, they probably thought, well, that doesn't accomplish much because 0 divided by 7 gives us 0. And they chose another data set. Same thing happened. And another one, same thing happened. In fact, you can prove that the sum of these deviations will always be equal to 0. So we have accomplished absolutely nothing. So in statistics, mathematics and statistics, when this phenomena happens, often a solution is to take these differences and square them. Now what that does is that's going to turn all of our negative numbers into positive numbers. So the reason we're getting this sum of 0 over here is because our negative numbers and our positive numbers kind of counterbalance. Now granted we've only got 2 that are negative, but you've got one that has a lot of effect because it's going to turn out to be an outlier, as you would kind of expect. So what they did here is they decided to square these things. So 4 squared is 16, 8 squared is 64, 14 squared, I think it's 196, 196, 36, 18 squared, I think is 324. 5 squared is 25, and 27 squared is 729. Okay, now let's add those numbers up. So 16, I'm going to do this on my calculator to save time. That's 1,390. So we can say that the sum of the deviation squared, that's a new one, right, is 1,390. Now, what they thought about doing is they thought about coming in now and taking the 1,390 and dividing it by 7. Well, I'm not going to get into the reason, but they found out that that's really not a good value to create when we're dealing with a sample. So they wanted to come in here for reasons, again, that's too far advanced, I think, for a class of this level. And they wanted to divide by 1 less than the sample size. So we have 7 numbers here, and they figured out theoretically that it's better to come in and divide by 1 less than the sample size than it is to divide by 7, which is the sample size. So when they actually end this up, they end up with divided by 6, so they get 231.6666666. Now, that's kind of cool what they did there, but they realized that they had a problem. Now let's think about these x's. These x's back here measure something, don't they? And in our situation, they're exam scores. But let's think about, what if these were inches? Well, then this 78 inches minus 74 inches would give me inches in each of these situations. And then when I come in and square this, this is going to give me inches squared. And when I sum up a bunch of inches squared, I'm going to get inches squared. And when I take inches squared divided by 6, I get inches squared. But guys, we wanted a distance from the mean. We wanted this to be in kind of a one-dimension difference. We didn't want to get into two-dimension differences. So what would be the best thing to do to this 231.66666 inches squared if we want to get it back to a value in the original unit of distance, inches? Well, take the square root of it. So guys, let's think about what we got. Let's just go ahead and take the square root of that number. So I get 15.22. Okay? So guys, what have we done here? We have seen that we can take the sum of these deviations, differences squared, divide not by n, but by n minus 1, take the square root of that, and in our problem we ended up with 15.22. Well guys, this is probably the most important measure of center that I will teach you, and this is called the standard deviation. Now guys, just like from here on out, when we see x bar, this is a notation that goes with the mean. When you see s with a sub x there, and guys, sometimes, depending on the textbook, sometimes they just use s. This is the standard deviation. Now, both of these deal with samples. So what we're kind of talking about here is we're pretending that these numbers are a sample of something from a sample from a larger population. Now, later on, we're going to get into something called a population mean and a population standard deviation. But for right now, we're just saying, okay, we went out and we collected some data. We got a sample. How can we numerically summarize center and spread statements, of the measurements that we collected from our sample? So all this deals with sample stuff. Okay. So one more thing, if we take away the square root and just look at the sum of the x's minus x bars squared over n minus 1, and don't look at don't take the square root, notice here we got 231.67. Guys, we call this the sample variance. So the number underneath the square root, this part right here, we call this the variance. And in our problem, the variance is 231.67. Once we take the square root of that number, we create what's called the sample standard deviation. Now, a little technical here, but if we don't divide by minus 1, we get something called a population standard deviation, or if we don't take the square root, we call it a population variance. But we don't want to talk about that. We always want to, when analyzing spread in a sample, we always want to divide by n minus 1. And as you guys are going to find out, when we have something like this, we're going to use the calculator. So guys, let's talk a little bit about what we found here. Okay, we've got our 7 exam scores. And we wanted to find measures of center. We found that the mean x bar was 74. And we found that the median was, I forget, 79. We got into measures of spread. And we saw that the range was equal to, guys, I've lost all my notes here. I need to keep better. 45. And let's just go ahead and be consistent here. We always want to round these things to 2 places. We found that Q1 was equal to 60. We found that Q3 was equal to 82. We saw that our standard deviation was 15.22. Now, one additional thing I want to show you here, we have something what's called an IQR. And an IQR stands for the interquartile range. And what the interquartile range does, it gives us the difference between, it's really easy to find, gives us the difference between Q3 and Q1. Well, I see the Q3 is 82, and I see the Q1 is 60. So for this data set, the interquartile range would be 22. You guys, interquartile range is just the difference of the middle 50% of our data. Now, if I can go back and show you this drawing that I gave you earlier, the difference between here and here is the IQR, because we take Q3 minus Q1. And if we think about what we actually take care of right there, that's the middle 50%. This is kind of helpful when we have a lot of extreme values, high or low, a lot of outliers. It kind of gives us a more stable measure of center based on just the center 50%. So it's something that we will encounter and report. All right, gang, let's have some fun. I can't even say that without laughing. Let's learn how to use this fancy schmancy calculator that you guys were required to go out and spend some of your hard-earned money. If you haven't bought it yet, you probably need to. You could get through the course without it, but I'm going to also show you how to do all this stuff on R. So let's see. Let's get the data set here. Now let's go to the calculator, and let me show you some stuff on it. All right, so gang, if we want to do this stuff on a calculator, this is what we would do. Get it big there so you can see it. All right, gang, first thing you're going to want to do is come into your Stat button. And I like this, the way this does it, because it'll make the key red that I hit, okay? Now, there's some stuff going on here. You've got Edit, Calc, and Test. So if I go over to right, you're going to see that we have all sorts of different options. You're going to learn a lot of that stuff eventually, but for right now, we're going to keep it simple, and we're just going to learn how to edit and enter data, okay? So we want to hit Enter to be able to enter our data. Now, this is going to happen to you. If it's a new calculator, it probably hasn't happened. This may be blank, but ultimately you're going to have numbers there that you're going to want to get rid of. Now, the worst thing you can do is just go through and start deleting them one by one, because you may get into data sets of 40, 50 long, and you're going to be there for a while. The easiest way to delete the numbers and not delete the list is to go up and highlight the list and go Clear, Enter. If you go Clear, Enter, it's going to delete all the numbers there, but it's going to keep the list. Now, inevitably, I will tell you this, but students won't listen to me. And they'll go up to L2 and they'll think, well, I want to delete. Well, if you do that, it's going to take you literally. It's going to delete out the list and the numbers completely. It's going to delete everything. Guys, you don't want that. You want to keep the list. You just want to get rid of the numbers. Now, if you need to put that back, just go Second Function, Insert. And if you look above 1, 2, and 3 in blue letters or yellow, depending on the type of calculator you have, you'll see L1, L2, L3, and so on. Well, I want to put L2 back there, and I'll hit Enter. So you can get it back, but it's frustrating, for that to happen. So guys, L2, if I want to get rid of the numbers, just highlight the list, don't hit Delete, and hit clear enter, and it gets rid of the numbers. All right, gang, what I want to do is I want to type the numbers in my calculator. So I'm going to type in 78, hit enter, 82, 60, 80, 92, 79, and 47. Now, we got a small data set here, and I wanted to start out the first one manageable, but I always like to go back up and highlight the last number. This number you see right here in the parentheses will tell you how many numbers that you've entered. 7 is small and manageable, but sometimes if you get into a data set of maybe 50 or 100 and you've got to sit there and type each one of those in there, it's easy to make a typo and forget one. So this will kind of keep you honest. It won't tell you the accuracy of the numbers you typed in, but it will tell you whether you typed in the correct number of answers. All right, gang, what I'd want to do next is I'd want to go to Stat. I'd want to go over to Calc, and I'd want to go to one variable stats. Now, depending on the type of calculator you have, and I want to demonstrate the other operating system here in just a second. So I'll tell you what, give me just a second. I want to type these in real fast in my other calculator that I'll show you in just a second. Okay. Now, depending on the calculator you have. Now, if you have this operating system, this is what you need to listen to. If you have the other operating system where it actually put the one variable stats back in the home screen, I'm getting ready to show you what you need to do. So, guys, we put our data in L1, so that's cool. Frequency list, we don't have a frequency here, so we come to calculate and hit enter, and you'll see you have one variable stats. Okay. Now, for those others of you, let me show you what you would encounter. If you have this type of calculator, so I've entered my data into L1, okay, and the next thing I would do is hit Stat just like before, and then I would come over to Calc and I would hit enter, but something different would happen. What would happen with this calculator, this operating system, is it will put one variable stats back into the home screen. So again, all you got to do, if you look above your L1, L2, L3, L4, L5, L6 keys, in blue or yellow letters, depending on your calculator, you will see L1, L2, L3, and so on. Well, I put my data in L1, so I need to hit second function 1 to put an L1 there. And when I do, I will get the answers. All right. Now I'm going to go back to the other screen because once you get that, the answers are the same. And it's the beauty, I think, of taking a class like this online is if that went too fast for you, all you got to do is stop it and rewind it, and you can make it happen at your speed. Well, gang, at the top we see X bar is 74. So I want to have a couple things going on here. I'd like to well, it won't let me do that, will it? All right. Yeah. So we can see that X bar is 74. You can see that this SX standard deviation, it took us about 20 minutes to figure out, is 15.22. Matches up with the answer that we got here. N is 7. That's our sample size. Now this arrow right here, this down arrow, tells you that there's more stuff down there to see. So if I come over here at the down arrow and scroll all the way down, you'll see that it gives us an additional 5 numbers. Gee, I wonder what we call that 5 numbers. So we call it 5 numbers the 5-number summary, right? So our minimum value is 47. Our quartile 1, first quartile is 60. Median is 79, which we knew. And our Q3 is 82, which we also knew right over here. because our maximum value is 92. I had a student, it was actually kind of cute, a student actually flip out on me about 2 or 3 years ago, and they're like, well, yeah, Dr. Darbro, but it doesn't give you the IQR. All right, okay, you got me. It doesn't subtract 82 minus 60. But I don't think that taking 82 minus 60, performing a subtraction with a calculator, is a heavy-duty expectation. I don't think that's too much to ask of a college student. It also doesn't give you the range, right? The range, the highest number was 92. The lowest number was 47. So your calculator isn't that clever, is it? It doesn't give you the everything, but what it doesn't give you requires a simple subtraction with a calculator. Enough said. Okay, let's see how we do all this.